Hey everyone, welcome to another Trimble Monitoring Power Hour webinar. I'm excited for this month. We have Cobus from Optron joining us for a great webinar on implementing an automated monitoring system. And we're going to dive into a use case on how to do that, specifically on dam monitoring. So with that, I want to urge everyone, if you have any questions throughout the webinar, there is a little chat or a questions pane in the GoToWebinar panel, and you can go there and type in any questions you have throughout the webinar, and we'll answer those as we go. So please feel free to ask as many as you want. In addition, if you're having trouble hearing us or you're having trouble seeing the presentation, please let us know in that chat window as well, and we can address that in real time and get that fixed so there's no technical issues. Aside from that, though, everyone sit back and enjoy the webinar, and we'll start with introducing ourselves today. So myself, I'm the product marketing manager for the Trimble monitoring and tunneling teams, and I'm based in Westminster in Colorado in the United States. And today, I'm excited to have Cobus joining us. Cobus, go ahead.
Yeah, thank you, Riley. Good afternoon, everybody, or good morning, wherever you are. My name is Cobus Botha. I'm the subject matter expert for deformation monitoring and infrastructure for Optron in South Africa.
Excellent. And so really excited to have you with us today. So with that, I'm going to let Cobus take the reins here, tell us about Optron and what they do, and then we're going to get into all of the goodies what you all came here to talk about, how to implement a monitoring system from start to finish.
Okay, so first let me just introduce you a bit, tell you a bit more about Optron. So Optron has been established in 1986 in South Africa. As a Trimble dealer, we have a staff complement of more than 60 people currently, and we've got offices in Centurion, Cape Town, Somerset West, Durban, also Nairobi in Kenya, and then we also have a wide network of resellers and agents throughout sub-Saharan Africa. We've been a Trimble dealer for over 50 years, and we have a factory-trained, certified, and dedicated technical support services, as well as a level 3 certified service center. So we don't have to ship any hardware components back to get serviced. We can service them ourselves. We've got a dedicated support help desk. It's open during office hours. And we are a trusted Trimble partner for monitoring and course installations. And we've been involved in monitoring since 2009. Currently, we've installed probably over 60 individual automated monitoring stations at around 20 sites in 9 different countries throughout Africa and even beyond Africa as well. And we've also installed over 60 core stations in about 5 different African countries. And then we also installed and maintained the Steenbras Dam T for the demo monitoring site, which will be the main attraction at the end of this presentation. So first of all, what we're going to talk about today is how to develop your monitoring system and how to do the installation from the start, from the RFP or request for proposal and quoting stage. Then we'll look at the pre-implementation stage, the system installation, configuration and testing, and then well as post-implementation. So if we look at the quoting stage, things you need to look out for is, what is the project specifications? Are the project specifications relevant and clear? If they're not clear, then don't be afraid to ask clarifying questions to the client, because in the end, what you want to quote on is the correct items, and you don't want to find that out at a later stage. What is the scope of works? Who will be responsible for which task during the installation? So sometimes the client will be responsible, if it's, let's say, for instance, on a mine, the client will be responsible for constructing the pillars for orientation, as well as the concrete platforms where the monitoring station will be installed. So that needs to be made clear right from the start. So which Trimble components are we using for this installation, for instance, and what software are required? So if it's a new customer, you will only perhaps have a couple of node licenses and maybe software warranties that you need. Sorry, if it's an existing customer. If it's a new customer, obviously you need to decide on which version of T4D do they require. If it's only geotech equipment, you can do Trimble Geotech. If it's more than that, you might need to look at T4D Advanced and such. So what third-party equipment do you require during the installation? So that would be IT components like servers, the Wi-Fi radios to get the communication back from the field to the office, etc. And then what equipment enclosure types needs to be used on site. So we've got quite a wide range of enclosures that we use for monitoring installations. So first of all, we just have a normal sort of like a cabin that the instrument is housed in. And this is useful, for instance, for dams or even on mines if it's not close to a blasting activity. If there is blasting activity, we can install the same cabin, but then we can actually build a blast cage around it, which can be closed up when they do blasting and then open up again when it's safe to do so. And then also, if we don't need such a big enclosure, we can just build a small enclosure that sits around the total station just to protect it. If a stainless steel cabinet that houses all the electronics.
Hey, Cobus, before we go on, just a question on that last slide.
Okay.
For the project specifications, can you give some examples of what would be like examples of where you get relevant and clear ones versus some that would need clarifications like that you've worked with in the past?
So in some cases, it will not be clear if there will be permanent electricity supply. Will it be solar power, for instance? Will the client be responsible for the Wi-Fi network, or even just the positions of the monitoring stations? So sometimes the client will just say, well, we need a monitoring solution, but they don't really know what exactly they want to monitor or where the station should be and such.
Gotcha. Thank you.
Okay, so then we also need to look at the professional services that needs to be offered. First of all, it's always a good idea if it's a new customer to include the cost for a pre-installation site visit. Preferably, you actually want to do this site visit even before you provide your final quotation. And the reason for this is during this site visit, you can actually clear up a lot of the items that we discussed in the previous slide, and the customer will also be much more aware of what will need to happen on site. And sometimes we can also make recommendations of exactly where to place the monitoring stations. We need to look at your installation duration and personnel. It's always quick to say, yes, I can give you a quote quickly. There you go, installation is included. And you maybe costed for 2 days of installation. And when you start actually planning the installation, you see, but this is going to take like 5 days or so. So you need to be clear before you do your quote that you know exactly how long, or more or less how long the installation will take. You also need to look, if it's a new customer, more than likely there will be a training requirement. And if it's an existing customer, they might also require maybe a little bit of refresher training. Otherwise, some customers just say, listen, just come install the device. We know how it works. You also need to look at what's the health and safety protocols. So on mines, generally you have to do inductions, you have to do medicals. So you need to take that time into account, because that is all time that will cost you in the end. You need to have your personnel on site for that time, but you're not really getting any value for it. So you need to build that time into your quote as well. and then any travel associated costs like flights, accommodation, meals, etc. So for instance, to give you an example, for us to fly from Cape Town, where I am based, some sites it's easy. You fly to Namibia, it's a one-way flight, straight flight for 2 hours, and you're there. Other flights, if we fly to West Africa, for instance, it might look something like this, where you have 3 different flights over 3 different days. And all of that, if you take that into account, the cost of that, it can all accumulate at the end. Then, of course, you need to look at what the current COVID-19 regulations are for where you're going. Some places might still require that you quarantine when you arrive there. Other places will only require a vaccination certificate, for instance. And then lastly, for the quoting stage, we need to look at what shipping methods and costs and the duration of that shipping will be. And then also you need to make clear who is responsible for the duties and clearances of these devices if it's an international shipment. Okay, so then we can move on to the pre-implementation stage. So once again, as we talked earlier, the site visit is very important. And during that site visit, remember to take a tape measure along. Otherwise, sometimes we've had in the past where you had to measure the height of a beacon just using a book. And then you come back and you say, well, the tape measure was 3 book lengths high, and for instance. So tape measure is nice and small, pack it in, it will save you quite a lot of time. At the site visit, liaise with the client with regards to the site preparation and the IT requirements. And then you follow up on that constantly to ensure that the site preparations are being done and that is complete before you actually get to site. Make sure you order all your components timelessly and also take into account, especially now the global chip shortages, that you take into account manufacturing and shipping durations. It's easy to say to a customer, yes, we can install next month, and then you want to order the devices and then you get a response back and say, well, the devices will only be ready in 2 months' time, for instance. So that you need to take into account as well. Implement the order fulfillment SOP or standard operating procedures to ensure that all your components and procedures are accounted for. It's much easier if you have a list that you're working to and you can tick off items on the list as it's being completed. And then once all the components have arrived, you can start with the assembly and integration and do as much as you can of this integration in your own workshop. So this, you won't be surprised how much time it will save you on site. Because here, if we assemble here in our own workshop, if we need a bolt and we don't have it in the workshop, we can quickly run to the shop and buy it. If you're on site, sometimes that means driving to a shop somewhere or trying to find a shop where you can even get it if you're lucky. And then test all the. Sorry.
I guess you know that everything is working together once you've set it up, right? Before
exactly,
you get on site and it's 40 degrees Celsius or something, and
exactly, because this allows you, if you build it in your own workshop, it allows you to be able to test the equipment before you ship it. And we've implemented a test sheet, so we also have a list that we run from the top. We test the voltages. We let the equipment run for at least 24 hours to ensure that all the what we call the burn-in, that all the electronic equipment is actually nice and stable and in working order. So this is just a couple of pictures of us. This was for Core's network that we've assembled all the electronics boards. So these boards all go into these white cabinets. And then we've just tested them outside, tested that the solar panels are actually working, that the solar controller is charging the batteries and such. And then this was just the construction of a glass cage for one of the monitoring stations. Okay, then very important, during pre-implementation, take detailed photos of all the assembled units. Before you ship as well, it just allows you, if you save all of those photos, that if the shipment gets to the other side or to the client, you can send them all the photos and say, well, this is what should actually be there, and they can actually verify that everything has arrived. And you can it also ensures that you have actually completed everything and actually added everything that's on the quotation. So pack the equipment properly in crates and prepare packing lists for this. It makes it much easier for the admin office as well, if they need to start preparing the shipments and dealing with the couriers. If they have a proper packing list, then it's much easier for them as well. Then we arrange the shipping agents to collect the items. And if we're shipping internationally, remember to arrange for custom inspections before the shipping, if it's required for that specific country. Okay, then we can carry on to the system installation. First of all, the best thing to do is prepare installation schedule. And don't wait until you get to site. Prepare this long in advance. So draw up the installation schedule. Either use Gantt charts or use it in Excel if you don't use Gantt charts. And in the schedule, take into account the logistics to get the team to site. So that will be your first item on that schedule is, for instance, we will say Optron team arrive on site. And we know our departure date and we know the arrival date that the guys will be on site. On the schedule, also ensure that you highlight the client and contractor's responsibilities. So for instance, if the client needs to provide local transport or pick you up at the airport, list that on that schedule. If they need to supply the power tools or the spanners, list that so they know exactly what they need to do. Otherwise, you might get there and then you only need to start arranging items, and that will cost you a lot of time in the end. When you get to site, best is to have a kickoff meeting and a site establishment. So first of all, we'll have a kickoff meeting, discuss with all the different role players exactly what will happen, and we then go through the installation schedule and highlight items of concern. And then we'll do the site establishment. In other words, we'll actually physically go check that everything is there, all the equipment is there, get everything ready, unpacked out of the crates, so that we can get started with the installation. So then we'll install the enclosures and hardware according to the project specifications. So sometimes it takes a bit of work to do this, especially the big enclosures. You will need to have a truck with a crane so that you can lift it up, because that needs to be lowered over the monitoring beacon.
So in that image there's a concrete pillar that's for a total station, right? And then that enclosure sits on top of the concrete foundation.
That's correct. So the total station will sit on this concrete slab, and this is just the concrete pillar. The concrete pillar is where the total station will sit, and then the cabinet will be on top of the concrete slab.
For total stations, do you always recommend like a concrete pillar for stability, or do you do other types of mounting?
We generally, if the client wants to build their own pillars, we prefer that it's normally, like you can see here, that's a HDPE pipe that's filled up with concrete and reinforcing steel as well. What we also do offer is we actually have a steel pillar with quite a wide base that we can mount to a concrete slab, and then we fill up that beacon, we fill up with soilcrete, so a mix of sand and cement. And we also find that is quite stable, and it makes the installation much faster as well, because you don't really have to worry about, like in this case, you can just place the cabinet and position it correctly, and then you mount the pillar from the inside.
Yeah.
Okay, so this is just another image of the installation. So on the side here, you've got the Wi-Fi radio, and this pillar at the right at the top of this pillar will be the temperature sensor, the temperature probe in a Stevenson screen. Okay, once again, same as with the pre-implementation, take detailed photos of the installation. Because sometimes if something goes wrong and the client phones you maybe 2 years down the line, you actually have photos of what it looks like on site. So it's not just, so anybody can then support the client instead of, otherwise you will just have to have the guy that was on site that can actually support him because he knows what the installation looked like. Then once it's done, ensure that you do a site handover to the client and make sure that the client is happy with everything, and to ensure that everything is operational. So get a signed copy of proof of delivery, and then what we also do is we actually give the customer what we call a customer satisfaction index. It's just a whole list of questions where they just tick off how the installation went and if they're happy or not and such. So once the hardware installation is done, the technicians can actually depart from site if logistics allows. Because sometimes we won't send a technician and the application engineer. We'll just send 2 technicians maybe in the beginning. They'll install the hardware and then they depart from site, and the application engineer will arrive on site to do the software part and the training. The application engineer can actually arrive, preferably arrive a couple of days before the technicians depart, so that it can overlap with the last part of the installation, so that both parties are available for configuration and testing. So that brings us to configuration and testing.
Hey,
First of all, what you should, yep.
Maybe one question before we proceed to the next area.
Okay.
Going back a couple slides, talking about the system installation, there's a question that came in about the enclosure. It looks like the enclosure has some kind of plexiglass window on it, correct? For the total station to measure out of?
That is actually not plexiglass, that is safety glass.
Safety glass, yeah.
So, yes, yeah. And so it's got safety glass in front.
Right. So the question is it not, like traditionally, I think this is something that comes up quite a bit. Is there any problems with the total station measuring through that? Or any things you have to consider?
We have never found any real problems. What you will find is sometimes when it needs to measure quite close to the corner of the glass, you might find that it will struggle a bit, but generally we don't really struggle with measuring through glass. And also because you do your initial setup through the glass as well, your environment does not change. So that little bit of refraction that you'll get through the glass does not impact the monitoring system that much, or at all, actually.
You're making the same measurement over and over again, right?
Exactly.
Gotcha.
Okay, so configuration and testing. So first thing we'll do is configure the IP addresses of all the components. Sometimes this is something that we'll even do in the pre-implementation stage, where we'll ask the customer beforehand, we need, let's say, four IP addresses per station, and they will provide it to us, and we can actually configure it here in the workshop already. So once we get to site, that's all ready to go. So very important, make a note of all the serial numbers of the hardware components. So the total station serial number, the setup M1 serial number. If you have other Wi-Fi devices on the cabin, make a note of that as well. Then we perform the site setup in T4D. So the easiest way to do it is actually just to connect the computer directly on the network at the cabin. We normally use remote desktop to log into the server, and then from there we can do the site setup. It's much easier to do the site setup if you're actually standing by the total station than to have somebody by a total station and then another guy sitting at the server and you phone each other. That one should not be there. Let's double, sorry. Then we configure all the other relevant settings. So for instance, the round scheduler and the alarms and all of that. Then we test all the components to see that it works properly. And then once all the stations are operational and everything is measuring in T4D server, only then will we carry on and configure the sensors in T4D web. Because sometimes you will find that you will have orientation errors, and those orientation errors will cause spikes in your sensor data. So we first sort out all of the errors that we have there, so that we can have quite stable data. And once we know it's stable, then we configure the stations or the sensors in T4D web. And it's just to yeah, sorry
to interrupt you. Would those errors come from like geometry of the network, or what kind of things would you have to watch out for?
That's correct. That's correct. Sometimes when you receive the coordinates for the orientation beacons from the client, it might have been measured using GPS and not total station, for instance. So when you do the site setup and you have a look at your residuals of that orientation network, you will find sometimes that you will have a couple of outliers. And that means that even if it misses just one orientation beacon, that will cause a spike in your monitor data.
Mm-hmm.
So what we tend to do is we do the initial setup and then we remeasure all the orientation so that it from the start all the orientation and the total station position fits well together within this let's call it the localized monitoring network.
Cool.
Okay, then in T4D web, ensure that you have the correct email server settings for the alarming, and then run a test email in T4D web as well to internal and also external email addresses. I've had many a times, well, you'll only actually do it once, you'll make this mistake once, but I've tested the system once where I've put in the correct details and I've sent it to my own email address, a test email, and it just would not work. And every time I would run back to the IT guy and say, but you gave me the wrong settings. He would give me the same settings again. And then eventually we found out that the email server is not configured to actually send emails to outside email addresses outside of the company, only to internal, or that specific server was set up to only send to internal email addresses. So once I tested it to an internal email address, everything worked fine. And then take screen grabs of all the settings so that you can compile a configuration document once you're done with the installation. Configuration document will help you immensely in the future, because that means if something goes wrong, or if you want to add something to the system, or even if you just want to provide a serial number to the service center of a total station, you can go look in the configuration document and you can get all of that information in there. So the items we normally put in there is the IP addresses, relevant usernames and passwords, serial numbers, and then all the modules in T4D server as well. Then post-implementation. So your training plan must form part of the installation schedule. So when you draw up your installation schedule in the beginning, is take into account how long you will spend on training, and then also compile your training agenda so that you can send that as part of the installation schedule. Okay, then the customer also needs to ensure that the correct personnel are available. There's no use to train the admin lady on a mine in T4D. They need to ensure that they have the correct and relevant personnel available to attend the training. Ensure that your training venue is sufficient and that you have a projector available. This is something that's not always possible, but most companies, or most big places where you will have a monitoring system will more than likely have a boardroom and a projector available for you. And then I find for me that something that works for me is to compile a separate PowerPoint presentation for each section that you want to cover. For instance, this is just my folder structure, so I'll have a folder with presentations for the introduction to T4D, and then I'll have another folder or presentation for GNSS. If you look at terrestrial, for instance, I've got a folder for terrestrial, and then in there I've got about 10 different presentations, one covering the total station, one covering just the data collector and station setup, because this allows you to go through the presentation, and then once you're done with the presentation, you can actually then dive live into the software and show that specific section to the customer immediately after showing the presentation. A lot of customers, they get bored with the presentations. They don't really want to. They want to jump forward. The important part is to sort of convince them that the presentation is actually much needed, because it gives you all the information about that specific module. And then once they then actually see it live in the software, then they understand, but why did you bore them in the first place?
Yeah, and I guess it lets you tailor the training to what it is. If they're only doing total station monitoring, don't need to talk about GNSS or vice versa or something like that.
Exactly.
Or maybe you do need to cover it all because they're doing everything.
Exactly. Okay, and then keep the training factual but not too formal. So I like to sort of keep an informal class. I only have one rule, and that's no cell phones. And then you get the guys to ask questions. Don't wait until the end before they ask questions. Rather let them interrupt you, because otherwise you have to go back 3 or 4 slides, or sometimes even 3 or 4 presentations to explain it to them again. So rather, once you've ended the section, is to ensure that everybody is comfortable with that section, and then you can carry on. Have enough breaks in between sessions, because once again, PowerPoints, unfortunately, they are not always very interesting. So you have to have breaks to let the guys rest a bit as well. And it's a lot of information to take in. I've also found that sometimes it's easier to schedule, let's say, for instance, a 2-day training session for a new customer. And then in the quote, we've also built in to go back, let's say, after 3 months to do another, let's say, 3 days. Because if you show them everything in the beginning, it's very overwhelming, and you might as well almost have to show them nothing. So then also adapt the training program according to their requirements and skill level. So some guys only need to know how to check that the total station is working and how to take it off and put it back on and reset the reference circuit, where other attendees will need to know how to interpret the graphs that they see in T4D web and how to set up the alarms and so on. Yeah, as I said, now avoid information overload, rather arrange follow-up training sessions. And especially nowadays, we sometimes even do the training sessions online via Microsoft Teams, for instance, and we can do it that way as well. Okay, encourage them to ask questions immediately. And then also more important is that you ask questions from time to time to see if the attendees actually understand what you're saying. Because a lot of times, if you just say, everybody okay, everybody will just, I can guarantee you, everybody will just nod their heads and say yes. And then 2-3 slides later, somebody might ask a question that was on that exact slide where you said where you asked if everybody's okay. And then at the end, hand out a short assessment that they can complete at the end of the training, just so that you can also gauge how the understanding was. And then I also like to sometimes ask 1 or 2 of the attendees to present some of the procedures, like adding Prisms to T4D web, just to to gauge the understanding of the subjects. And then we normally compile training certificates and hand them out at the end of the training. Okay.
So maybe before we go into this next section, there's a couple of questions came in about more on like system design, system installation. So one was how important is installing lightning and surge protection, or is that something that comes up often?
Okay, so for all our installations that actually have permanent electricity supply, we do install surge protection. And then especially if it's a country or a region where they get lots of lightning, we will actually ask the client to install an earth spike at the location so that it can be earthed and lightning and protected from the lightning as well.
Mm-hmm. Another one was about the types of power. You showed some solar panels earlier on. Is that most common type of power for monitoring, especially I guess total station, but maybe it's different for other sensors?
Actually, the most common that we find is to have a permanent electricity supply. It's also the easiest one because we still install backup batteries. So if that electricity supply goes down, the backup battery will continue running. But if there's no, we sort of try to install solar as a last resort. So we first try to push for a permanent electricity supply, and then if the customer says, well, it's really not available, then we'll go for solar. And we normally install 200 amp hour batteries in that cabin. So your system, if you only have a total station, it will probably, without sun, it will probably run for at least 2 or 3 days.
So you have that kind of backup just in case the solar can't give you full 24/7.
That's correct, yes.
Cool. Thanks for the good questions, everybody. If you do have any others, feel free to keep typing them in. I'll keep going with the presentation for now.
Okay. Okay, so next we'll do this, just a case study of Steenbras Dam, of the monitoring system we've installed there. So Steenbras Dam consists actually of a couple of dams. The main dam is an arch gravity dam. The customer is the city of Cape Town, or the owner of the dam is the city of Cape Town. Location is Gordons Bay in South Africa. It actually sits on top of the mountain. The goal for this monitoring system is to just monitor the dam wall continuously for movement, and there's also some existing cracks that we want to monitor as well. The Trimble advantage in this is that we get the data confidence by using T4D for reporting and alarming. And then the equipment we use, because this is actually a demo system for us, we tend to, you'll notice there's some older equipment here, because we tend to use what we have. So we have one Trimble S8 long range fine lock total station. We have about plus minus 16 prisms. I think there's a bit more. We've got 4 Neta 5 GNSS receivers as well. We've got some geotechnical sensors, quite a wide mix of geotechnical sensors, you'll see later. And then obviously we have the T4D software. So just the background of Steenbras Dam. So Steenbras Dam phase 1 for the construction was completed in 1921. At the time, it was only a simple masonry construction that was about 8 meters tall. Then later on, the wall was raised by about 13 meters using a concrete structure that totally enveloped the old masonry construction. And then in 1970, it was raised by another 7 meters. And then Steenbras Upper Dam was constructed in 1977. And the dam is used to supply water and electricity to the city of Cape Town. So Steenbras Lower Dam is it's a 28 meters tall concrete arch gravity construction. The dam wall is 412 meters long. It's got a capacity of about 36,000 megaliters, catchment area of 66 square kilometers, and a surface area of about 380 hectares. In the Steenbras upper dam is a 34-meter tall earthfill construction, 940 meters long, 31,000 megaliters, and 263 hectares surface area. So the requirements for the monitoring system here is to have monitoring prisms mounted against the wall, to monitor the overall stability of the structure using GNSS receivers, to have real-time measurement of the reservoir water level of both dams, of Steenbras upper and Steenbras lower, and then to incorporate this. The last one was a new requirement for the last couple of years, is to incorporate GNSS monitoring of boreholes in the Table Mountain Aquifer project. So we'll get to that a bit later.
Is there a question on the things that are monitored are being monitored? Are they related, or are they all for a distinctive use? Like, for instance, is the GNSS measurements also being used in conjunction with the water level, real-time water level, or are they all for different pieces of the dam monitoring scheme?
No, it's all different pieces that fit together in one monitoring system. So not except for the last one, the monitoring of the boreholes. All the other devices actually are just for the stability of the dam wall.
So it's all these different, different components trying to get all that data together to make better decisions on the monitoring of the dam.
That's good. That's correct. Yes. Okay, so the location of Steenbras Dam is about 50 kilometers east or a little bit southeast of Cape Town. So there you can see on the picture here at the bottom right, that's where Steenbras Dam sits. So the prisms that we use the normal 62 millimeter monitoring prisms, as well as a couple of mini prisms as well, the 25 millimeter prisms. They are fixed on top of the wall, and they installed to face the instrument position. So we have not installed any on the face of the dam wall as well, because that it's quite difficult to get to. You have to abseil and such. So at the moment, we're just concentrating at the top of the wall. So you can see there's one of the prisms, and if you look at this dam wall here, so you've got this lower portion where the handrail is, and then you've got a upper portion as well. And we've got prisms on top of the upper portion. At each location where we have prisms, we've got one at the lower portion and one at the upper as well. And the reason for that is because what we would tend or what we were told is that these pieces are actually separating from each other. So we can actually then see if there's any real difference in the movement between the bottom section and the top section. We also have 4 reference prisms that are mostly drilled into rock, solid rock, away from the dam wall, so that we have nice stable positions. Then the total station is a Trimble S8 long-range autolock total station. We tend not to use the robotic because in the way that we assemble our electronics, you don't really need a robotic total station. The autolock will do just fine. And then we've added the protective enclosure. So this is just what our enclosure looks like at the top. So there's our total station. We've even got a camera inside. We've got a weather station, Wi-Fi antenna, and also a GNSS antenna on top of the cabin, which just monitors the overall position, long-term position of the cabin itself, just to as a sort of a second check on the total station position. That's just a picture from the back, so there you can see it's facing the dam wall, and the prisms are installed all along that top edge at the back. Okay, and that's just from the inside. And then this is our electronics board. I don't know if you can see my cursor on here.
Yep, we can see it.
Okay, so top left, that is our weather station data logger and the network link for the data logger itself to connect it to a TCP/IP network. Then we've got the setup M1 and OctoHub because we mainly use it in a local network and not via the internet or the IST Connect portal. This is just the Neta 9 for the antenna on top of the dam wall, on top of the cabin. Bottom left, we've got our AC power coming in, our electricity supply, and that feeds to the charger. So this charger is from Victron Energy. I think I've actually, no, I didn't take a picture of that. So that's from Victron Energy. So it's a smart charger. It will detect automatically what the current state of the batteries are and charge it accordingly. And if the batteries are fully charged, this charger will actually just operate as a power supply to all the electronic devices. And then this device, this black device over here, is our Ubiquiti edge router. So that creates a VPN link between all the devices here at the dam and the server which sits in our office in Somerset West. So these electronic boards are what we tend to build up in the workshop before we take it to site. And as you can see, there's quite a lot in this situation, there's quite a lot going on. So if you have to build up all of this on site, it will take quite a long time. Then for the water level monitoring, we actually use piezometers in both dams. I think our one piezometer is from RST and the other one is from Geocon. So we don't really have a preference to which brand we use. Then we also use, for the one piezometer, we use a load sensing wireless data logger and the load sensing gateway. And then for the one at the lower dam, that is actually connected to a Campbell Scientific data logger. So we use various options as well. The one linked to the Campbell Scientific data logger is quite old, a lot older than the other one. And that is also, at that stage, we did not have the load sensing units yet. So this is just the piezometer installation at the Steenbras upper dam wall. So this is probably about, the upper dam wall is probably about 5 kilometers away from the upstream from the lower dam. So this is where the load sensing devices comes in very handy, because we only installed the piezometer. We don't need to install power or network over here. It's all getting taken care of by the wireless data logger. And this is just us while we installed it, because obviously there's no, to get to this location at the bottom, you have to use a boat. So the guys had to row a bit to install that piezometer. Okay, then we've got quite a number of tilt meters on the dam wall as well. So this is just a uniaxial tilt meter, so it just monitors tilt in one direction. And to just show you, that is actually where it's installed on the dam wall, and it monitors any tilt happening in the direction of those arrows. Then we also, right next to it, we actually have a biaxial tilt meter as well. And this just monitors in both axes. So upstream, downstream, and then left to right as well. And then quite recently, we've added a load sensing laser tilt meter. So it's the tilt meter that measures in both axes, as well as a laser distance meter. So we've specifically added this one so that we can actually monitor the gap across the overflow as well. So we're constantly monitoring that gap as well, using the laser distance meter. Okay, then onto the Genesis monitoring. So the locations of where they are installed is just where the arch begins, and then both sides of the overflow we have some receivers, and they are installed in a stainless steel cabin. in the bottom drawer, there's 200 amp hour batteries, and then the top just houses the charger and then the receiver itself. And then as you can see, we've actually installed antennas, so they are co-located with a Prism as well. So we monitor this position using the GNSS as well as the total station. At the moment, we're not using integrated survey, we're just having them as separate points, but at least it gives you that extra check. And then we have a fixed position installed high up on the mountain, quite far away from the dam, which we use as a reference position for all the other GNSS points. Okay, so then we get to the Table Mountain Aquifer project. So it's quite an interesting project. They've drilled a number of boreholes between, so Steenbras Dam sits about, I think at about 340 to 400 meters above mean sea level. So these drill holes, we had quite a big, for those who do not know, we had quite a big period of drought here in the Western Cape. So this project, they've drilled drill holes about 800 to 1,200 meters deep into the Table Mountain Aquifer, which sits way under sea level. And then during times of drought, they can actually pump that water into the dam. And at each of these locations, we've installed a GNSS receiver to monitor the subsidence of the ground, of the earth. So if they see that it subsides too much, then they know that they're pumping out too much water and they can stop before they damage the aquifer. So at each pump station, there's a concrete plinth that's actually now just cladded of stone. So this plinth is actually, goes down, I think about 500 mils or even a meter down below ground level. And then we've got the antenna mounted on top of that. So that's just another image of that. And then this is all linked into our T4D software as well. Then for connectivity between our GNSS stations and the main cabin on site, we use Ubiquiti Wi-Fi radios. So at the cabin itself, we have a Ubiquiti rocket with a sector antenna, which I think it's a 210-degree sector antenna. And then we also have a couple of Ubiquiti nano beams at each station that communicates to that point. So we don't have to have a separate, let's say, modem or device at each GNSS receiver. We just have these Wi-Fi point-to-point radios. And then the cabin itself has wireless internet. So this Wi-Fi dish looks to a high point of a wireless internet provider, which sits quite high up on the mountain. And then, as I mentioned earlier, we use the Ubiquiti Edge router to create a VPN link between the field and the office. So at the office, we also have an edge router, and those two devices speak to each other. And that way we can get all the data to the server. Because our office is probably about, as the crow flies, it's probably about 15 kilometers. If you go by road, it's more than 40 kilometers almost. Then for power, as I said earlier, we've got 200 amp hour deep cycle batteries and a Victron Energy Blue Power charger. And then we also have at the one station, or at two stations, we don't have full-time electricity, so we have solar solutions installed at those stations. Okay, then we can look at the monitoring software. So obviously we are using Trimble 4D control. So all the devices feed their data into Trimble 4D control, which computes it, and then we can visualize the data in T4D web. So the server will normally be installed in a server case like this. And as you can see, this has also got a UPS, so that it does not uninterrupted power supply, so we don't have any power issues at the server itself. So just if we have a look at T4D server. So this is all our modules. You can see all the modules loaded here. There's quite a number of receivers in here because we actually use some of TrigNet, which is the local or South African cores network. We actually utilize some of their receivers as well as reference positions, as to provide sort of like an outside check, a long distance outside check to the entire monitoring system.
So it's like a kind of a core station kind of thing that you're using to compare to the receivers that are on site.
That's correct. So TrigNet operates about 70 core stations around South Africa. So we've used a couple of the closest ones. Yeah, incidentally, one of them are actually at Steenbras Dam, so it's quite close. And then we use, I think, 2 or 3 other ones, which is a bit further away. And then you can see there's quite a number of stations at the moment disconnected. That's just at the Aquifer project where they're busy working on the station, so they currently don't have any power. But at the bottom, you can see our data collector, you can see the integrity monitors. And we actually have 2 different integrity monitors for the terrestrial engine. So we have one where we hold the tilde station as a fixed position, and then we have one where the tilde station is actually not a fixed position. So it monitors the tilde station position as well using orientation beacons.
Is that to check if there's movement in the position of where the total station is located?
That's correct, because if you have movement in your total station, that movement will be translated to your monitored points. Mm-hmm. So it will look like all your monitored points have been moving, but essentially it's your total station that's moving.
Gotcha. So it's kind of like 2 different networks, one to monitor the structure, but one to also verify what is monitoring your reference isn't moving as well.
That's correct, yes. Okay, so then T4D web, this is just the map view of where all the devices are. So this is where the lower dam wall is. And some of our orientation beacons are up there, and that GNSS reference position is also up there. Steenbras upper dam wall is where this device is over here. And that's the piezometer that's installed over there. And then we've got the Aquifer project, which has got 3 GNSS stations at the moment. And then we actually have 1 cluster prism that we monitor, because we can see this point from the total stations. We're actually just measuring that point as well using the total station. It's quite a long distance. It's about, I think, 1,800 meters or something away from the total station.
Okay.
Then the nice thing about the T4D software is that we can also use, like in this case, a custom view, so where we can upload any image, this image is not geo-referenced. So once you've uploaded your image, you can drag your positions or your sensors to the positions where they should be, and then you can view the displacements and all of that on this image itself. So it's very helpful, especially on a dam, or for instance on a mine, on a high wall, where you can have a side-on image, and then you have your sensors shown on that side-on image. Then of course we also have various analysis graphs set up for the system. In this case, one of them is just the downstream prisms. We also have one, for instance, which just has the rainfall and the water levels combined into one graph. So we can see if it rains, then you can see that actually a couple of days after it rained, the water level rises. And even the upper dam level, which is quite interesting, it's part of a pump water scheme, so you can see the water level go down during the day as they generate electricity, and then in the evening from about 10 o'clock, when they pump that water back up to the dam, you can actually then see the water level rise up again. And then of course we can also have composite views, where you can see multiple different items on the same screen. So you can have your chart over here for that point, and then you can have the custom view where you have your photo, and then just the alarm status, current alarm status. All of this is in one graph on one page, and then this page can be shared with anybody on your network. So you have a URL that you can share with anybody, and they can then open that URL without having to be able to log into the T4D web software, which is perfect for, especially on mines where they have a control room. You can have, for instance, your alarms and a map that displays the different alarm levels in the icons of the sensors, and then you can take and open that on a screen and constantly view that and see where the problem areas are in real time. Then for configuration and testing, this is just some images as we tested it. This is not Steenbras dam, this is another dam. But once again, as I explained earlier, it's easier to do your site setup and your testing when you're actually at the total station itself. And here we are just setting up the Wi-Fi network and a GNSS monitoring point. And then we did some training as well. So as you can see, sometimes the training venue is not perfect, but you have to make do with what you've got. And of course, always the obligatory training photo. And then just some lessons learned, just to provide you some lessons that we've learned throughout the year, throughout all our installations, is that site access is not always straightforward. I mean, so here you can see we had to install the total station at the position right at the bottom of this hill. And it was so steep, we actually had to tie a rope to one of the trees so you can actually just pull yourself up. And it was quite hard work. So plan the installation well to ensure minimum time away for your crew, because they also have families and they don't want to stay away for 3-4 weeks at a time. Try to arrange weekends, work over weekends on site if possible, because that will shorten your installation duration. If you can't work over weekends, then you have to stop Friday afternoon and then the guys just hang around there over the weekend. It's easier just to work those 2 days and let the guys maybe come back on a Monday or a Tuesday, and they're only away for a week and a half instead of being away for 2 weeks. Wildlife can be a problem, especially for us here in Africa. Snakes, monkeys, baboons, all of the above can give you lots of hassles, so just be careful of that. And the cultural differences can be a big challenge, and you must just manage that accordingly. So if you see a problem arise, rather address it immediately. All cultures are different, so it's sometimes is a big challenge. And then test your equipment prior to shipping. We do sometimes, you do get devices that get to your office and you install it, you switch it on, and that just the lights won't even come on. So then at least you're still here in your workshop. You can replace it with a different unit, and you can send a working monitoring station to site, instead of having to get to site and then find out that the devices are dead. And make sure you've got adequate tools for your project. Once again, this is part of your, when you draw up your installation schedule, is make a tool list as well, and then provide that tool list to the customer. More often than not, they've got all the tools available. If they don't have the tools available, you must just make a plan to get those tools to site and get them back again. And then have fun and enjoy it. It's not all the trips are not just all work. You have to have a bit of fun as well. Enjoy the local delicacies. And that's it. So I just want to say a special thanks to City of Cape Town, and then also to Trimble as well. And then lastly, if you want to stay in touch with us at Optron, you can find us on all the different social media pages, LinkedIn, Facebook, Instagram, YouTube, and even our website, www.optron.com. And be sure to follow us for some proper content of installations, not just monitoring related. And yeah, thank you very much.
Thank you, Cobus. There's been a couple of good questions, so maybe we'll, I know we're a few minutes over time, but let's take a few questions because I know a few of you have probably been waiting for answers before before we end this. So one question from Christian came. So I think this one, there's this two-part question. One I think is directed at me, one's directed to you, Cobus. So I'll ask the one part that I think is directed to you first, which is how many projects like Steenbras Dam have you done? And in terms of size, is there projects that you've done that are smaller as well as bigger in terms of like the monitoring scheme?
Okay, so in terms of dam monitoring, we've done probably about seven different dams throughout the years. Some of them bigger, where they have got 2 total stations, multiple GNSS, up to 300 geotechnical sensors installed. Other ones, some of them are smaller, where we've only got a couple of GNSS sensors. And then in terms of mining, so our main focus is actually on mining and mine monitoring. So we've done probably about 15 different mines of various sizes. Smallest installation is just 1 total station. Biggest installation is actually a mine that's got, I think, 6 different stations.
Cool. Yeah, I think that was kind of the second part of the question was, can T4D be used on like kind of scaled? Can it be used on a small project? Because obviously the Steenbras Dam is fairly intensive monitoring scheme and kind of scaled. And short answer is yes, as Cobus mentioned, you can have as small as a single sensor monitoring project, a single total station, and you can scale it up based on whatever the project needs to up to thousands of sensors. So there was another one coming through. Yeah, this is actually a good one. How do you prevent theft, or is that usually a problem? Is there different mechanisms that you put in place to kind of ensure sensors don't get stolen? Or I mean, I'm sure in some cases when it's dropped into the bottom of the dam, like in the water, you don't have to worry too much. But do you consider that, Cobus?
Yeah, it's a good question because you can't really prevent theft. If a thief wants to get into your stuff, he'll get in, no matter what you do. But we, for instance, for the stainless steel cabinets, they've got the bottom door and the top door has got, there's 3 locks in total, so 2 for the electronics door and 1 for the battery door. Mm-hmm. And those locks are actually enclosed with a steel structure, so you can't get in there to sort of take a hammer or a bolt cutter and nip it off. The cabinet itself has got locks on the front, on the door itself. And then especially if it gets to mining, the guys tend to then rather put a fence around it, and then maybe some mines they even have a full-time security guard sitting at the station. Depends on how bad the theft situation is in that area.
Another one came in. I think this one I can field was about deploying T4D on smaller projects and for paying for it more in a kind of like smaller chunks. So the T4D can be purchased in a perpetual license, like a lot of your standard desktop software, but there's also term-based licensing. So if you're doing a smaller project or even a short-term project where you don't need it for long periods of time, there's monthly and yearly term-based licensing for T4D. And so that reduces the upfront cost of paying for the software. And typically that's what I would recommend, especially for smaller projects where you might not need the monitoring system for years, you might need it for months. So thank you for that question. Another good one was about ventilation and for the enclosure. I think is where the question is getting at. Does that total station enclosure that you have, Cobus, does it get like foggy, or does it require some type of ventilation?
No, we don't really put any ventilation in the total station cabinet itself, for the pure reason of actually preventing any moisture to get inside. Mm-hmm. But it does not really get we haven't really had any problems where the glass actually fogs up, because it's quite a big enclosure, so you have, the air sort of moves around quite freely in there.
I think we'll take one more just because we're 10 minutes over time, and apologies everyone if we didn't get to your question, but we can follow up afterwards as well. So we'll do this one here from Kevin. So what this for you, Cobus, what typical time frame between receipt of notice to proceed and system, or sorry, what is the typical time frame between notice to proceed and the system actually being operational on site?
Okay, so we normally, from the date that we receive a purchase order, if we have everything in stock, we can probably, let's say shortest time, if we have everything in stock, will be probably 3 weeks to shipping date. And then once we've shipped, depending also where you ship to, let's say that's another 2 weeks, and then maybe another week or 2 on site. So you're looking at about let's say roughly about 2 to 3 months. Shortest time, 2 months, with longest time, maybe about 3 months.
Right, maybe we'll take one more just because I saw this one pop up and I think it's a good one. So a question about geotech sensors. So a lot of tilt and geotech sensors have their own software. Would you still use T4D to share, visualize the data? Yes, maybe Cobus, you answer, yes, and then I can answer.
Yes, definitely, because the nice thing about T4D is that you can bring in that data, even if it's not, for instance, so currently we standardize on the load sensing devices, but even if you have just your own geotechnical sensors that can just output a data file, you can bring that data file into T4D, and in the end, you have all your data together in one package, and you can have alarming on all of that data from one single package instead of having to jump back and forth between different software packages.
Yeah, I agree. Yeah, and I think that's a good point to the question. Is in most cases you prefer to only work in one area, right? If you can, especially if you have all these different sensors from different manufacturers, right? You want to kind of centralize that in one place instead of navigating between all these different platforms just to view the data. All right, I think with that we'll call it now. We'll call it end of the webinar. Thanks everyone for the great questions and for attending. I know there was a few we didn't get to, so I apologize for that, but we can follow up after the call. And just so everyone is aware, this was recorded, so if you do want to watch it again, you'll receive an email with the recording. You can also share that with your colleagues or anyone in case they missed it. I want to say a big thanks to Cobus and the Optron team. This was a great webinar, and you're probably out of breath because you're talking for about 50 minutes straight, but it was great information. And I can just tell by the questions that everyone learned quite a bit from it, so really appreciate that, Cobus.
It's a pleasure. Thank you very much.
Awesome. All right, everyone. So we'll end the webinar for now, and stay tuned for, we'll have another monitoring webinar in April. Right now, we're looking at doing something on rail monitoring, and so stay tuned for that. You'll see a registration link come out quite soon via email or on social media on LinkedIn. You'll see those available here in the next few weeks. If not, you can, or in the meantime, if you want to look at any of the previous webinar recordings, you can go to that website link there on the geospatial Trimble.com website. And with that, thank you all. We'll end the webinar now, and we'll see you next month. And thanks again to Cobus, and take care, everyone.